Hi, today I'm talking about LeetCode problem 1381, design a stack with increment operation. Personally, I really love this problem. This is the kind of LeetCode problem I like. I think it's fun to create a data structure that will allow you to perform some operation efficiently. So what this problem asks you to do is to create a custom stack class. And the custom stack class needs to support these four operations. It needs an initialization function that's given a max size, and that tells up to how many elements your custom stack can hold. It's given a push function, which can take an integer, and that's going to push the integer that it takes onto the top of your stack, unless you've reached the max size, in which case do nothing. You can pop, which is just going to return the top of your stack, or -1. And you have this kind of bespoke function, increment, which takes a k and a value. And what it will do is it increments the bottom k elements of your stack by value. So those are the four operations. In case you're not familiar with the stack, I just drew this little illustration. The stack, like a stack in real life, you push things onto it, or you put things onto the stack, and they kind of build up, starting at the bottom. Next thing you put on, next thing you put on, next thing you put on, and so on. And when you pop elements off the stack, then you get the top element of the stack. So if you push 5 and then 4, and then you pop, you would get 4. Pop again, you would get 5. Pop again, our thing says you would get -1, and you would just get -1 indefinitely while you pop like that. And the only kind of unique thing about this stack is that it supports the increment operation. So you could have these numbers on your stack, and you could call increment by, say, k, meaning the bottom k values you're going to increment, and you could give it a value, and that would just give you, so here I'm saying increment the bottom 2 values by 10, so then I'd expect 11, 12, then 3 and 4, like that. And that's kind of the only unique operation about our stack as opposed to stacks generally. But as we can see, if we needed to support this operation, I don't know, maybe designing a custom stack or something like that might be useful. So let me talk about how I did it, and I'll explain more what I mean about that. So this first function is my initialization function, and remember it needs to support taking a max size. So what I do is I just set a member of this class to be equal to the max size that we take as the argument. And I'm also going to initialize a current size variable. And that's because I want to keep track of how many items I currently have in my stack. Now, the data structure that's going to underlie my stack, that's going to support me storing and accessing data, is going to be a list. So you may think, well, why can't you just get the size of your list, of your underlying data? And one reason for that is that I don't want to be calling the length function all the time. I think that's going to be slightly slower. That's going to take up some time. But a bigger reason is that I don't want to be appending and removing things from my list, actually. I think appending and popping off of the actual list is going to take time. So max size means we can have a fixed size for our underlying data structure. We never have to have more elements than max size. So I'm just going to save the time of actually pulling things off a list and putting them on, and just have a max size that tells, or a current size, which tells me how much of my list I'm using. And so here I'm initializing the data member to be, this notation just says a list containing a list of 0, 0, multiplied by the max size. Or in other words, it's going to create for us a list with max size, a list with max size of list of lists. So I realize that's kind of a mouthful, but what it's going to create for us is just, if I said max size is 3, it's just going to create a list of 3 of these. And that multiplication notation in Python. May look kind of weird if you're not familiar with it, but that's what that means. So that times 3 would give me this. Yeah, that's what that means. And so the 0, 0 part of it is, I think, potentially strange as well. And I must confess, I actually got this idea after I had solved it the first time. I had something like a 60 or 70 percentile speed, and I was reading the discussion forums to see how to get even faster. And this is something I found reading the forums. But we're going to use one of these two values to store what the value is, and we're going to use the second one to help with the increment operation. And I'll explain that more in a second. So our push function, what it's going to do is if the current size is less than max size, then we're good to push stuff in. So increment our current size and just put into the current size index a new list. A new list containing the value that we're trying to push. And while I'm talking, it just occurred to me that we could actually just do this. And I think that's going to be even faster, except this may have a problem with our increment pop. Yeah, so this may have a problem with our increment, but I want to go back and see if I can correct that later. Anyway, the pop function, if our current size is less than or equal to 0, meaning you're trying to pop when you have no more elements, we're just going to return -1. That's per the definition of the problem. And otherwise, what we're going to do is we're going to get the element in our data list at the current size less 1. And we're going to decompose that into a value and an increment. So remember, the element at our data list sub current size -1 is going to be a list itself with two values, 0, 0. And so what's going to go into our value variable is the first element from the list. And what's going to go into the increment variable is the second element from the list. Then we're going to decrement our current size. I guess to be even more efficient, slightly more efficient, we can just do this, and now we save one subtraction, which I'm sure is negligible. Anyway, if the current size is greater than 0, we're going to say, right, so if our current size is greater than 0, meaning we still have elements in our list after we've popped one off, then we're going to increase the increment value, or the second value of the latest remaining element in our list by increment. And I'll explain more about that in 1 second in an illustration when I talk about the increment function. But for now, we can just think of that as something that's useful for us. And then finally, what we do is we just return our value plus our increment. So yeah, that is, we're finally doing an increment step that our increment function doesn't actually do. And so finally down here we have this function increment, and what it does is it adds to the second indice in the indicated list the value that we want to increment by. So when I say indicated indice, that's the minimum of either k minus 1, because k is telling us the first k elements, and in our list it's 0 indexed, so 0 would get us the first element. So we're finding the min of k minus 1 or the current size -1. So we're just saying, like, only do this increment up to the current size. If our list size is 3, if we only have 3 elements in our list, and we try to increment at 4, we just want to increment the bottom 3, not an element that doesn't exist in our list. And so what it's doing is it's marking the second element in our 2-element list as increasing by val. So let me just explain slightly how this works. Rather than just a list of lists, rather than just a list containing the values in our array, in our stack, we have this two-dimensional list. So it's like this. Oops. It's like this. 0, 0, 0. And the reason for this is if we just implemented increment naively, then we'd have to visit 1, 2, 3 elements. We'd have to visit each element in our stack and increase it by increment. This kind of smarter way of doing increment, if we want to increment by 2, say we want to increment by 2, 5, what we do is we just find the second element in the list, this one, and we update this by 5. And so now we know if we ever pop 2 off, we ever want to pop 2 off, we add 5 to it, and we push 5 down to the number right below it. And so that means we don't have to add to every element. It makes increment an O of n operation, meaning it happens in constant time. No matter how many elements we have in our stack, it's always just one operation for us to go increment this value by 5, or increment this value by whatever we want. And so that's why we're pushing it down in the pop function. If you have an element below you when you pop, then we're going to increase your increment counter by whatever we just popped. Because remember, increment should apply to not only the element that you're incrementing, but also all the elements below it in the stack. So let's see, can only concatenate list, not int. So I actually expected this to work as is. I must have changed something. Can only concatenate list, not int to list. So why is this not working? What did I change here? Oops. This is, I just copied this out of my submission history. So let me, so what did I change there? I said, well, at any rate, I'll fix this when I'm not recording. So this winds up getting something 99.7% faster, so pretty fast. Although, again, I did copy the increment strategy. Without that, it's maybe 60 percentile speed. But I think we can actually make this even faster. I'm going to let this video extend by maybe 1 minute while I try to make it slightly faster, because I think what we can do is here we can just say the 0 position becomes x, and the problem is that if there's a stored increment variable there, then we want to overwrite that. I wonder if that's any faster really than like overwriting 2 values. Is that any faster than creating a new list? I guess we'll see in 1 second. And the other thing, so I feel like this could go here. This is all I meant to change. I don't know why that didn't work last time. No, something doesn't like that. Okay, well, I won't debug this while recording live, but I am going to experiment more to see if I can go even faster than 99.7% of other submissions. So if you enjoyed this video, let me know by clicking the like button. If you want to see more LeetCode problems solved, I'm going to try to do 1 a day. So yeah, subscribe to the channel, say something in the comments. Thanks a lot.